Hi, my name is Ellie Hart, and today I will be discussing how to solve for the reaction rate law, rate constant, and order of the reaction from data. So here is our question. The tabulated data were collected for this reaction. 2 nitrogen dioxide gas plus 1 fluorine gas produces 2 nitrogen dioxide fluorine gas. And our molarity, concentrations, and rate are given in the table below. The problem instructs us to write an expression for the reaction rate law and calculate the value of the rate constant K. What is the overall order of this reaction? So we're going to need a few equations to do that. Here's our generic reaction rate law. We have rate equals K, the rate constant, times A, the concentration of reactant 1 molarity to the N, which is the rate order of reactant 2, times reactant 1 times B, which is the concentration of reactant 2 in molarity, to the M, which is the rate order of reactant 2. And to solve for the rate order, we're going to find two experiments where one of the rate molarities change and one stays the same for our two reactants. And we're going to set the larger rate over the smaller rate and set that equal to the concentration in the experiment with the larger rate over the concentration experiment with the lower rate. And we're going to put those to the rate order for reactant 1. And so in this situation, you'll see K cancels, and then you can get a value for A1 over A2 to the N. You get a value for that, and then you get a value for the rate, and then you can solve from there. And our rate order is going to be equal to M to N, the rate order for reactant 1, plus M, the rate order for reactant 2. And here's our data, just copied over, same thing. And let's start with nitrogen dioxide. Let's look for the two experiments where we have the concentration of nitrogen dioxide changing and the concentration of fluorine gas changing. And you'll see that that's here in experiments 1 and 2. So we're going to put the larger rate over the smaller rate and set that equal to the concentrations times K to the N. Concentrations to the N times K. I don't want to make that clear. K is not to the N. And so we're going to end up with something looking like this. And so when we do this, we can cancel K, and then we can find a value that is equal to this and our value that's equal to this. And we're going to end up with 1.96 equals 2 to the N. And we're just going to solve for N, so N equals 1. And we're going to do the same thing with fluorine gas. We end up with, we're going to substitute in B's in this case because this is our second reactant. So we have B to the M instead of A to the N. But it's the same process. Let's find the two experiments where the molarity is changing for fluorine, but not for NO2, and we'll see that that is going to be experiments 2 and 3. And we can write it out here. And then we're going to do the same thing we did over on the left side. We're going to cancel the K's and then solve for these values, and we get 2.02 equals 2 to the M, which we can find out from that M equals 1. So our rate law right now will look like rate equals K times NO2 times F2. Since they're both to the 1, we don't need any exponents. And now let's solve for K. So we have rate equals K times NO2 times F2. That's what we found in our last experiment. So we're going to pick an experiment and plug the values in. Let's do experiment 4 since we haven't used it yet. So here are our values for experiment 4, and we're going to plug them in just like that. 0.411 molar per second equals K times 0.400 molar times 0.400 molar. And when you do that, we're going to get K equals 2.57 molars to the -1 seconds to the -1. All right, and so then our final rate law is going to look at like rate equals 2.57 times NO2 times F2. Now let's solve for the rate order of the reaction, which is just N plus M. We're going to get N equals 1, M equals 1, so our rate order equals 2. And that is good because that matches with the units that we found for K. All right. So let's go through this summary. So we have the rate equals K times A, which is the concentration to the N rate order times B concentration to the rate order M. K is the rate constant, which has units that vary by order. And then we're going to find that those rate orders by using this equation here, rate 1 over rate 2 is equal to k times a to the n, a sub 1 to the n over k times a sub 2 to the n. Remember, we're going to pick equations that have one of our experimental reactants changing and the other staying consistent. So that's important. And then we wanted to put the larger one on top. Rates are going to be the rates in molar per second, and then the concentrations of a sub 1 and a sub 2 are going to be the concentrations in the experiments that correspond. So they should be same and same. All right, and finally, n plus m is equal to our total reactant order. So that's just we're adding up the reactant orders of the rate orders of each reactant, and then that's going to be the rate order in total. And then so this is our final answer. We would put this at the bottom of our page. Rate equals 2.57 times NO2 times F2. K equals 2.57 molar to the -1, second to the -1, and with a rate order of 2. All right, thank you. Hope that helped.